Good morning, and welcome to our lesson on electrostatics, our second lesson. And we saw previous lesson where charges come from, what kind of variety they're in, positive and negatives, what particles in nature actually provide these charges, which are electrons and protons, the only ones we know for now in this class. And we saw that in conductors, the electrons can move more easily, and with the insulator, they're not. Our lesson today will include this video and some other videos I've added in just in case you want to get another take at it. We will be looking at this PowerPoint together now, real quick. I have these two activities I want you to do on Physics Classroom. And this one, I want you to do level 1 only. And this one, I want you to complete all the levels. And then take this little assessment that tells me that you've understood what we've talked about so far. Okay, so starting up with our video. And well, actually, I don't want to go to the video. Let me go back to the PowerPoint. And here we are going to look at seeing how charges behave when you bring in other charges close to them. And we look and seeing how we can charge something. How do we make something positively charged or negatively charged? Or perhaps even determine later on what kind of charge it has. Remember, when these charges build up, they spark out, that we saw as static electricity in the previous lesson. And so here we're looking at a picture of a charged insulator and a charged conductor. What I want you to notice is how in the charged insulator, the charges are in one place. How did this happen? Well, I hope you remember from our last lesson that protons never move, so I did not add protons to this thing to make it positively charged. I hope you are thinking that, yes, I removed electrons from here, so I stripped some electrons off here, and that's what it looks like now. This area is void of electrons. Those other electrons from here can't move in here because they're bound to their own atoms. That's not the case when it comes to a conductor. In this conductor, we stripped away some of the electrons out of it, so that's why it's left with a positive charge. And the electrons have pulled away in such a way that the distribution of the positive charges or the charges of this are spread out evenly. They get apart as far apart as they can from each other. You could think of them as positive charges moving, but remember, protons never move, but it does appear in the same way because of the way the negative charge is distributed away, that we have, a net uniform positive charge. So now let's look and see what is polarization. So you see over here we have this Coke can, and this Coke can has been polarized. What we mean by polarized is that there is a kind of direction to this. The electrons have moved away this way and left behind a bunch of positive atoms in this area, and have moved to the right. And so we see this thing is polarized in the sense that one side has more positive charges and one side has more negative charges. And it's kind of like a direction to this thing now, which basically goes from positive to negative. It's kind of like something's been created in here, and this thing's been polarized. What's happened again, the charges have moved apart from each other. How did we make that happen? We brought a negatively charged balloon close to this can. The moment we did that, electrons from here said, don't want to be near you guys. So they zip over to this side, leaving behind a bunch of positive charges that we see here, and this part becomes negative. Okay. The second video following this one